Now we've tuned the hyperparameters of our logistic regression model and it's getting pretty good score here. But remember this score, the default score for a classifier is accuracy. What we want to do now is create some evaluation metrics around our model that go a little bit beyond accuracy. More specifically, let's create our tuned machine learning model. Actually, machine learning classifier is probably a better one because these evaluation metrics are specific to classification. So we're going to go beyond accuracy. So here, more specifically, we want an ROC curve and AUC score. We also want a confusion matrix. I'm putting 4s in there. That actually looked like it was from the matrix with lots of numbers. You know, that flowing green screen. We want a classification report. What else do we want? We want precision, recall, and F1 score. And it would be great if cross-validation was used where possible. So let's turn that into Markdown. So this is what we're going to be working on. We'll use our tuned grid search logistic regression model as well as the best hyperparameters for it. And we'll see where they come into play in a second. So first of all, when we evaluate a model, it's always comparing how our trained model's predictions compare to the truth labels. So what we have to do is make some predictions first so we can compare them to the truth labels, aka the labels in the Y-test dataset. So let's do that. We'll write a note here. To make comparisons and evaluate our trained model, first we need to make predictions. So what we'll do, we'll go make predictions with tuned model, and there's a beautiful function called predict that we can use for that. So we'll save it to ypreds, and we'll use gs logreg, which is just our trained version of our grid search model. So gs logreg dot predict, and we're going to predict on the test data. Ypreds, wonderful, and let's see them just to make sure we're not going crazy. Beautiful, and now we need to compare them to the test data set. So we have a look at this here. Okay, so if we wanted to go 0, 0, we can know it's got this one wrong because that's supposed to be a 0 there because this is the truth labels here. And then we could keep going through there, but we're not going to do that. We want to use some code to do that. So the first thing first, we want a ROC curve because remember that we've got this little list up here. So a ROC curve and an AUC score. What is a ROC curve? Well, if we look that up, so what is a ROC curve? We went through this process, so understanding AUC ROC curve. So if we were to read through this, what we would get is the ROC curve is created by plotting the true positive rate against the false positive rate at various threshold settings. Okay, beautiful. So let's see how we do that. The ROC curve is a way of understanding how your model is performing by comparing the true positive rate to the false positive rate. And if we want to figure out what a true positive and a false positive is, we can have a look at our confusion matrix for that. So a true positive, a model predicts 1 when the truth is 1, and a false positive is just the model predicts 1 when the truth is supposed to be 0. And a perfect model is going to get an AUC score, what we see in a second, of 1.0. So let's see how we do it. So import ROC curve function from sklearn.metrics. That's where it's from. That's where it lived. But we've actually already done this, as with all the other sklearn functions we've been using, right back up the top. Right back up here. So this is model evaluations. Right now in this next section, this next video, we're going to tackle everything from here. So these are, we can see here, we've got randomized search CV, grid search CV, confusion matrix, plot ROC curve, that's what we're about to use, precision score, recall score, F1 score. So these are for our classification model. So let's go down. We can save ourselves a line of code. We don't actually have to import that. We'll come right back down here. We can just go plot ROC curve. Now this is a relatively new addition to this scikit-learn library, which I'm very, very happy with because usually you had to write these on your own, this function, this plot ROC curve. And calculate, it actually calculates the AUC metric for us, so the area under the curve metric. Let's see it in action. I'm going to go plot ROC curve. GS log reg, and if we look up this in the documentation, it'll tell us what it does. Pass it an estimator, which is our machine learning model, pass it X, pass it Y, plot receiver operating characteristic, aka ROC curve. So that's what it's going to do for us. Beautiful. So GS log reg, X test, and we want it to do it on the test data set. Always evaluate, this should be calculate. Always evaluate your machine learning models in the test data set. And let's see. Oh, beautiful. Okay, so remember a perfect ROC curve we've seen in previous videos. We go up to this corner and then across like that, but ours teeters up pretty well. Then we get an area under the curve, so if we calculated all this area under here of 0.93, of course, a perfect model will achieve 1.0. So our model's not perfect, but it's an AUC score of 0.93 when the average of just tossing a coin, essentially, would be 0.5. So we're edging close to a perfect model. Not bad for a model that just came out of the box. All right, the next thing we want to do is a confusion matrix. So let's see that. So confusion matrix. How could we do that? So I think scikit-learn has a function, and I don't think, I know scikit-learn has a function. We can go confusion matrix, and we want to compare the ground truth labels with the predicted labels. Okay, we could just leave it as that. That's a bit bland. We can improve the visualization of this confusion matrix using Seaborn. That's what we want. So we want to go, I believe we already have Seaborn here. Yeah, do we? SNS? Yep, we do. So we've used Seaborn before in this project, so we can go, what I might do is I know ahead of time that we need a bigger font size. So font size equals 1.5. That's just sns.set. Now we're going to create a little function here in case we wanted to make another confusion matrix, because scikit-learn's confusion matrix function isn't up to scratch as of making this video. You could always, maybe that's an opportunity for a pull request. So we go here. Nice and simple. So we're just going to pass it, this function, our test labels and our predicted labels, and then we're going to create a nice looking, plots a nice looking confusion matrix using Seaborn's, we've seen this before, heat map. Wonderful. So we'll go fig ax equals plt.subplots, fig size equals 3, 3. Oh, shift enter, trigger happy again. Ax equals sns.heatmap, wonderful. And we're going to pass it the scikit-learn function, confusion matrix, y test, y preds. And then we want to add here a not, so annotate, yes, please. Annotate equals true. Then we're going to go cbar, because we don't want a color bar, because I've seen the color bar and it doesn't look too great on a confusion matrix. plt.xlabel, true label, and then we're going to plt.ylabel, we're going to go predicted label. And let's see it. So we're going to go plot conf mat, confusion matrix, y test, y preds. Oh no, what have we done? Font size. Dot set, got font size wrong. What is this? Tab? Oh, scale. There we go. Tab autocomplete for the win. Ah, classic. And it's giving us this little cutoff thing here. So we can fix this, I believe, by going bottom, top, equals ax.get ylim. Yep, and then we want to go ax.set ylim. Make it a little bit pretty. Set ylim, and it's going to be bottom plus 0.5, top minus 0.5. Now, of course, if your confusion matrix came out looking well, you might not need these lines, but it doesn't matter. There we go. We made it look a little bit better. So you can see that the model gets confused, so it predicts the wrong label, relatively the same across both classes. So in essence, there's 4 occasions here where the model predicted 0, the predicted label. So it predicted someone didn't have heart disease when they should have been predicted as 1. So that's a false negative, so it's predicting 0 instead of 1. A false negative, remember, as we come back here, false negative model predicts 0 when the truth is 1. And over here is the false positives. So AKA, we've got 3 instances here where a model predicts 1, someone does have heart disease when they actually don't. And you can see these are both things that we want to avoid, right? Especially when we're thinking about something as severe or as serious as heart disease. Even predicting when it's not present, so here if we predict 0, so no disease when it is present, okay, that's bad. But also predicting that it is there when it's not actually there, that's also bad. So that's something that you want to have to consider when you're building these type of models. Is a false negative worse or is a false positive worse? And again, a perfect model would have none of these, but in reality, you're going to probably end up having some sort of confusion here with your model. You're not going to, ideally, these would be perfect across here, across the line. Now, we've done a confusion matrix. We've got that there. We could share that with our boss. We could share that with our boss, a ROC curve there. What's next? Classification report. Okay, and it would be great if cross-validation was used where possible. All right, so that's what we might tackle in the next video.